Hello, my name is Andrew Just, and in this module of Forecast Builder, we will go through a demonstration of how to use the application. First step with Forecast Builder, when you pop it up in GFE, which is underneath the Procedures menu, is to choose a time period to work on. If you work here left to right, you have the first choice there of when to start, then when to end, and where to start. Where you could jump ahead in the process if you're okay with previous steps. And there's also optional items available that you can configure for your local office, such as, in this case, fire weather grids. In this example, I have the setting for aviation turned on, so you can see the 18Z TAF there shown. That 18Z TAF will be replaced with 21Z, 0Z, 3Z, etc. So the second step in the Forecast Builder process is the foundation grids, and this part is the most important. With the Forecast Builder GUI here, you have the ability to initialize grids with the best verifying data sets over the long term, short term, and incorporate observational data. Again, forecasters here should spend 90 to 95% of their total grid editing and collaboration time with these key grids. Everything that is done in this step will highly impact things downstream, such as creation of precipitation types, creation of snow amount ice accumulation, your non-precipitation types, and your weather grid. But note that when you do go through and edit these grids, you should take it from the approach of seeking targets of opportunity, those things that can impact actions of our stakeholders and partners. And again, do these modifications in a collaborative manner to maintain a high level of consistency from office to office. If you look in the GUI shown here, you will notice some elements: cloud-based primary visibility, low level wind shear, low level wind shear height. Those are part of the digital aviation services. And again, the aviation's turned on here for Forecast Builder, so you see those elements. And then down below is a listing of what gets initialized. And in this case, we have super blend, short blend, and conshort. The future goal here, though, is to utilize the National Blended Models and RTMA for your sources for short-term, long-term, and observational data. So let's take a look at a quick example of what would happen if you populate with those with the foundation grid step. You can see here the load-in's complete. And the moment these grids are populated, you should save these and share them immediately so that your neighbors have an idea of what was populated here. This is also the time to do collaboration and make fine-tune adjustments to these base grids. In this case, where I've initialized the short term, you may want to make sure that the first few hours of the forecast represent reality as close as possible. Next step along the process is to update your top-down grids. These top-down grids, you really only have to inspect for a couple situations. The first would be freeze and rain, second is sleet, and the third is when you have rain with a deep cold isothermal layer. An example here given where you have a warm nose of just 1 Celsius that extends all the way up to 2,000 feet. Now, if you're in the summertime, when the temperatures are warm, the Forecast Builder will just skip this step automatically and be like, we don't need the top-down grids. But if your hourly temperatures start to fall below 40 degrees, then this step will show up. Models with good vertical resolution and AWIPs are incorporated in this step. When you load into this step, you will see grids like the NAM, the Canadian, the GFS, and RAP show up so that you can see what those models are producing for these grids. A good reference for this is in the science modules on top-down training. Also, one last thing of note here in the top-down step is the ability to edit road temperature grids. These grids are useful in situations when you have a cold road and you're starting to rain, and that rain can result in icing on the road. Or vice versa in the spring when you maybe having freezing rain due to the air temperature, but the roads are warm because of solar insolation. More of that can be found in one of the Nabology modules on the probability weather type. Here's an example of the top-down grids. Again, similarly to the foundation grid step, you would want to save and collaborate these grids with your neighbors. Note that modifications to these grids can greatly impact precipitation type and your accumulation. Again, the model data will be usually a good starting point. You'll just have to go in and maybe make some tweaks, especially right at the get-go to make it match reality. Use your RayUp data, AMDAR data, your GOES imagery to help adjust some of these parameters. Alright, so again, most of your work has been all done in the foundation grid and top-down step. Now you're at the point where you're ready to create the various precipitation types and also do some integrity checks on the grids that you have done up to this point. During the process of creating precipitation types, snow and ice accumulation, there's going to be a lot of background science and statistics running. They're going to generate, again, the precipitation type probabilities, the snow, sleet, and ice accums. When everything falls out, if you don't like the output, do not go through and change the precipitation probabilities. Do not change the snow, sleet, or ice accums. Go back in the process. Collaboratively change either your foundation or top-down grid, because we're trying to make sure that the process remains meteorologically consistent from start to finish. So again, these foundation and top-down grids formulate how the precipitation types, snow and sleet and ice, fall out. Again, this step, as you come into it, there are a variety of integrity checks running, such as checking the temperature versus the max min T's, the dew point versus temperature, QPF versus pop, etc., and derivations for derived parameters like apparent temperature, max min RH, these morning and afternoon dew point grids. So let's take a look at a quick example of the precipitation types and accums. The results should be relatively seamless, especially if if you're consistent with neighbors on the foundational and top-down grids, where everybody's using the same process, so therefore the snow and ice will fall out to be consistent. Something that's neat here to kind of do a quick SA is that when this step runs, if you have any ice accumulation, even 100th, those in your CWA, those grids will light up and give you a little clue of if you're getting any ice coming out of that process. And also, there's these grids, ice flat accum and ice line accum. Those are currently mostly experimental. They're produced by the freeze and rain accumulation model, and these could have future DSS utility to tell power companies in that how much ice accumulation could be expected on power lines versus what's actually going to be accumulated on road surfaces. So again, they're experimental, but something to look at for curiosity. Now we move on to the fifth step, which is your non-precipitation types. There are a variety of tools here provided to help you produce the types, such as science-based studies for frost and blowing snow. Note that field-driven improvements continue on these non-precipitation types through more science, technology, and empirical infusion. So here's a quick example for the probability of thunder, where we've utilized a blend of model probabilities such as the SREF, the gridded lamp, and the MOS guide. But note that you can also utilize POP. Forecast Builder allows you to choose between which process you want to go through, and the one with the POP method is very simple. It just copies the POP to the probability of thunder. And more on this can be found in the probability weather type module on non-precipitation types. And finally, the last step here, step 6, deals with updating the weather grids. 95% or more of the time, the defaults that are shown in the GUI are fine. There's quite a few options here provided to give you a little bit of flexibility, but again, most of the time you should be fine just leaving the GUI alone. What's neat too is that the forecast builder process here for weather grids will automatically bring in convective watches to enhance the weather grids. So for example, if you have a tornado watch in effect, any thunderstorms in the grid will automatically get put to T+, implying severe potential, and those Tor watch hazards that are shown in the center of the GUI there will also apply. Weather intensities are derived from QPF and snow amount. So this is nice as you you can resolve consistency issues from forecaster to forecaster and office to office. So the intensity here at your office will match that of another office if your QPF and Snowmont grids are consistent. And again, as mentioned earlier, this GUI adds the level of flexibility control before the weather grid is generated. So again, you can go through and modify options as needed to help you get to the weather grid that you would like to see. So here's a quick example of what the weather grid will look like. You might be looking at that grid that's shown and be like, whoa, that's way too much stuff. Well, when you get into complex weather situations, especially multiple precipitation types, you can expect the weather grid to look messy. But the NDFD, the GFE formatters, and point and click will handle this messy output. That's been confirmed via multiple years of having this technique in place. Note that we are looking into ways to simplify weather. So, this could be changed over the next several years. Well-collaborated foundation and top-down grids will translate to well-collaborated snow, ice, and weather. So, assuming that you've done all your good work to keep foundation top-down consistent, you can assume that your snow, ice, and weather will be the same with your neighboring offices. So with that, if you have any questions or would like to get more documentation on Forecast Builder, there are a variety of links here provided. Feel free to email the Forecast Builder group with the email address there, nws.forecastbuilder@noaa.gov. And thank you very much.